Hello class, welcome to our third lesson dealing with triangles. I know we've been kind of going a little slowly on some of these topics. Just to recap a few things that we've already talked about, you should be able to identify a triangle by its types of sides and types of angles. Remember, there's two descriptions at the same time, okay, to be able to determine that. Some other things about triangles that we've discussed is making sure you know if three side lengths can make a triangle or not. So that's something that you might want to refresh and recap from our first lesson. Today we're just going to spend a little bit of time reviewing some things and then look at an extension of section 7.3. First thing here to talk about is just combining like terms and solving an equation. So what you'll notice here on the left and right side is there's some pieces of constants that can be put together. So this plus 4 minus 2 becomes plus 2. 10 minus 2 becomes 8. And then from here, it should just be a two-step equation. Remember, start with the least important, add, subtract. So to get rid of plus 2, I'm going to add subtract 2 on both sides. And then to get rid of divide by 3, I'm going to multiply by 3 on both sides and get an answer of 18. Your goal is that your work should look similar to that. You might write it more horizontally, might write it more vertically, but you need to get everyone needs to be continuing to get better at how to set these up and how to solve them. The second one, what you'll notice is there's a 9x here and a minus 2x. So 9x minus 2x is 7x. So you just take 9x and then subtract the 2x, combine that together, okay, and you get 7x. From there, it's 7x minus 11 equals 14. Get rid of minus 11 by adding 11 to both sides, and then divide by 7. 25 over 7. Now don't forget, there's a few ways that you could set this up. One way is you just leave it as a fraction. 25 over 7 is really a pretty good answer as an improper fraction. That's just 3 4/7 and you're done. I don't have to worry about what the decimal is necessarily. Some of you get really stuck on finding the decimal, when in the end you could just save yourself a little bit of time and leave it as a fraction. If that type of question had a decimal answer that was needed, I know sometimes that happens on a test situation, you'd probably just round to the nearest hundredth as you find that answer. Okay, for the first piece about triangles we're going to look at is the topic of the angles of a triangle, always adding to 180 degrees. So for these questions, we're just going to add the three angles up. So if we take 45.7, 55.2, and 79.1, add them all together, we get 180, which means this is a triangle because the three angles add to perfectly 180. So we don't have to worry about changing anything because it already adds to 180. The second one is fractions. Now I caution you, okay, not to just change these to decimals. I know it's very tempting for like 1/2 and 3/4 to change them to decimals, and it will work here. But if a question starts as a fraction in your homework, try to work with it as a fraction. Because all that's going to happen, what could change here is that we could make this like 1/3 and 1/6, and they have repeating decimals that don't work as well. So you want to make sure you're paying attention to that idea. The other thing for this is we find a common denominator of 4. So I made this 2/4 instead of 1/2. You'll notice that in my example here on the right side. I just added up the whole numbers and I get 178 and added up the fractions. Remember when you add fractions, you add the numerators. So 2 plus 3 is 5, plus 2 is 7, and then the denominator of 4. And then this is that improper fraction idea. 7 out of 4 is actually 1 3/4, so I add 1 more to the whole amount, and I get 179 3/4. So the question is that a triangle yet? Excuse me, and the answer is no, because it's not exactly 180. Then it says, if it's not, change the first angle so that it does form a triangle. You don't get to pick which one you change. It has to be the first one. So let's think about it. We're at 179 3/4. I'm off by a fourth. So I need to add 1/4 to that first number. And so 31 and a half or 2/4 plus a fourth would be 31 3/4. There's a lot of direction reading at that point. You got to make sure you change the first angle to make sure that it adds up to be 180 then. Okay, some other things that you're going to see is just solving for an angle. So when we solve this triangle, the three angles should add up to 180. So I'm always going to set it up like an equation. So it'd be 12x plus 70 plus 62 equals 180. I add the 70 and 62 together, and that's 132. From there, it's 12x plus 132 equals 180. Now I know there's other ways to find this answer. You can expect a teacher to ask you on a question like this to write and solve an equation. Okay, for full credit, you're going to have to be able to do that. So you want to work on that skill as we're going through some of these scenarios, and you should get an answer of 4. Another way that you could get this number is by adding these two angles up and subtracting them out, and that's 48, and set 12x equal to 48. That's the same step as the second step on my equation here. I just want to make sure we're clear that we need to set up equations for some of these so that we can continue to work on that idea and get better at it as we move forward. The next one has a right angle. Now, the most common mistake on this question is people forget that there's a 90 there, so they don't add it up. Okay, so what I decided to do on this question is kind of like the second version I talked about, which was I know the three angles add up to 180, so I take 180 minus the 90-degree angle minus 36. So I get rid of the two angles, and I know that angle here has to be 54. I set -2 plus 14x equal to 54 then, because I know that has to equal 54 in that corner. To get rid of -2, I do its opposite, so adding 2 or positive 2. Okay, and I add 2 to both sides, and then I have 14x equals 56. From there, I need to get rid of the coefficient to divide by positive 14, on both sides, and I get x equals 4. Now, I just went through those two questions fairly quickly. Key things, make sure it's an equation that you're looking at to find the value of x so that we can figure out how to continue to improve on that skill set. The other thing is that you may have noticed I didn't classify the triangle, or at least I didn't talk about it. Okay, so this question here is a right triangle because it has a right angle. It's scalene because all three angles are different, which means all three side lengths are going to be different. This one previously was an acute triangle because all three angles were acute, and it's scalene because none of them are the same measurement, and so none of the side lengths are going to be the same measurement. Those are ways that you could lose some points on a test if you forget to read some of the directions. So think about that as you move forward. Next thing to look at is similar triangles. Remember, similar triangles have all three congruent angles, which means they're all the same measure, and the side lengths are proportional. So the key here is I'm going to set up a proportion. I know this 35 goes with the 7, so that's where 35 over 7 comes from, and then 45 over x. Now, I know there's other ways to find this answer. 35 divided by 5 is 7, 45 divided by 5 is 9. I want to make sure everyone can at least set up the proportion idea, so please try to do that as you're looking at your questions. On all these slides with the similar triangles, I tried to show like if it was acute or scalene. I'm not going to focus on that idea as much because the focus of the question is more about the cross-multiplying idea and simplifying, and solving for the variable. But that's there for your to be available for you in case you want to practice that and make sure you're on the right track. The next one we have 10.3. So 10.3 goes with x, so that's where the 10.3 over x comes from. And 4.2 over 16.8, that's where this piece comes from. You just cross multiply is an easy way to find it. If you find a relationship from left to right, the early ones will probably work out really nicely, but as you keep moving forward in some of your questions, it might be a little bit more challenging. So you want to be able to cross multiply to be able to set them up, and you should get an answer of 41.2 for the value of x. One thing to think about is some people accidentally divide instead of multiply. It should make sense that that number should be larger because the original numbers on the left side are smaller than the ones on the right because the triangle was smaller on the left versus the right. The next question has a lot more numbers involved, but you just had to pick one and match them up. Since we already know they're similar, you could have used 10.5 and 115.5. I chose to use 3.9 and 42.9 because they're just smaller numbers. That was just my choice. And then I have to use x and 132 because they go together. So I've got 3.9 over 42.9, and then x over 132. I showed the cross multiplying on this one as opposed to some of the others. 3.9 times 132 equals 42.9. I'm going to find that number and then get x by itself by dividing by the coefficient, 42.9. Okay, that idea should kind of get more and more routine and automatic. Okay, cross multiply and then divide to find your answer. And you should get an answer of x equals 12 for that situation for that similar triangle. Okay, this is where things kind of get a little weird because the triangle's tilted and moved or in a different spot. Look small side to large side. So small side here is 5, large side here is 60. So that means x goes with 156. If I cross multiply and solve, 5 times 156 equals 60 times x. I'm going to divide by 60 on both sides, and I will get x equals 13. Now, what's interesting on this one is this is one of the few cases you could probably get away and explain to me, well, I didn't need to show cross multiplying on this. And I say, well, why not? Well, these two side lengths here are both 156, which means it's an isosceles triangle. It's also an acute triangle because all the angles are less than 90, but it's an isosceles triangle because these two side lengths are the same. So if those two side lengths are the same, in this picture over here on the left side, these 13s had to be the same. So I could have probably gone that route as well to be able to find the answer of 13. Sometimes you just get on autopilot and you keep doing cross multiplying. You're going to do the same thing every time, and that's totally fine as you're looking at some of these questions. Okay, this next one is a little bit hard to tell kind of what numbers go together. I think the obvious ones that go together are this 15.9 and 5.3 because they kind of look like the longest side across from what looks to be like an obtuse angle. So for this question, I'm going to match these two up and take 15.9 divided by 5.3, and that's 3. And so to figure out which other ones go together, if you take 10.8 divided by 3.6, it's also 3, which means those two have to go together, which means x goes with the 11.1. If you would have picked 11.1 with 3.6, it wouldn't have been exactly 3. So you know those two side lengths can't go together. Sometimes when side lengths are close, like this 10.8, 11.1, you may have to go that route to say, okay, I have to figure out which ones go together first before I actually solve this question. And so then I would have 15.9 over 5.3 equals 11.1 over x as my cross-multiplying approach. The other option, this is a divide by 3 idea, 15.9 divided by 3. That's why this becomes 3. And so 11.1 divided by 3 will also give you 3.7. The questions that we've looked at today, the ones when you solve for x inside, like these ones, I want everyone to try to work on setting up an equation of some type. Okay, so your goal is to get an equation set up that you can solve and you can show your work in a systematic approach. I know there's other ways to solve it. We want to keep working on the skill of solving an equation, though. And for these other questions, I know there's easy ways, especially early on because the numbers are easy. But some of you are still struggling with cross-multiplying because you try other methods, but when a test comes around and the numbers get a little bit more challenging, you're not sure what to do. So let's keep working on this cross-multiplying approach so we can solve, much like this one right here on the right side. So let's keep working on that approach as we move forward in this lesson. Okay, the homework is from section 7.3 extension. Okay, so there's section 7.3. We've already done the 2 days on that. And now this is the extension. So it's just the next part of your textbook. And I believe it's on page 288 and 289, numbers 1 through 17. Let's make sure we work on our equations and cross-multiplying approaches to solve some of these questions. Have a good day, everyone.